Okay, so you're going to be on page 524 in your math workbook. What we're going to be working on is the same thing we worked on yesterday, which is you're graphing your numbered patterns, and you're going to be continuing that today. But this time, I guess today you're really going to be doing the number patterns. So look at number 1 on page 524. It says multiply the number of nickels by 5 to find the number of pennies that equal the value. So again, it's relationship between your nickels and your penny. So it's telling you that your pennies, if you would really look at it, P is your pennies, so it would be it would be 5N. 5 times your nickels equals your pennies. So obviously it would be 3 times 5 is 15, 4 times 5 is 20. So again, the relationship, so if there's 3 nickels, there's 15 pennies. There's 4 nickels, there's 20 pennies. 2 nickels, there's 10 pennies. So then I would go and I would graph them 2, 10, 2, 10. 3 is my input, my nickels, so my nickels would be here, and my pennies would be my output. So for 3 pennies, I would have how many nickels? 15. 4 nickels, I would have 20. So again, looking, these are my pennies, these are my nickels. My input is my nickels, which is my x-axis. My output is my pennies. Okay? Same thing with number 2. Add 5 to the input to get to the output. So all of these are adding 5. So 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, 4 plus 5 is 9. Nothing new that we've talked about. Again, there's no title to this, so I'm not sure what we could say the relationship with. But again, so if I'm looking 1 for my input, this would be my input, this is my x-axis, and this would be my output. So if I have 1 input, my output would be 6. The relationship between my input and output is adding 5. So 2 plus 5 is 7, so therefore my output is 7. My input was 3, my output would be 8 because 3 plus 5 is 8. 4 plus 5 is 9, therefore my output is 9. Okay, nothing new. Alright, so look at the page 526. This is going to be a little bit difficult because it's talking about your relationship, okay, about the X and your Y or your input-output. So Ted gets $10 allowance every week, and he saves $6 of it. He makes a graph to show his savings. So let me just stop and go back. So if he gets $10 in allowance, is this about allowance? No. And he saves 6. Yes, so we're worried about the savings. No offense, Ted, we're not worried about how much you get. We're worried about how much you're saving. Where the X coordinate represents the number of weeks, so your X, which is your input, this is your weeks, if you want to say weeks. And then your Y coordinate represents the number of dollars saved. This is the dollars. The question is, which of these following ordered pairs could be on your graph? So let's look at it. It's hard to look at it because I'm thinking, well, I don't know. Well, let's see. After 1 week, how much does he save? He saves $6. 2, he's going to save $12. 3 weeks, he's going to save another $6, which would give me $18. So without looking at your ordered pairs, what's happening here? What's happening from my weeks to my dollars? Again, it's the relationship between the weeks and the dollars. So I'm multiplying what? 6. 1 times 6 is 6. 2 times 6 is 12. So that means my X and my Y, my X and my Y, so I'm looking at it. To get from my X to my Y, I'm multiplying it times 6. So this would be 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. So over here, then I'm going to look and see which one is correct. 6 times 6 is, no. Is 36 times 6, 6? No. Is 1 times 6, 6? Oh, geez, I hope it's D. 6 times 6, 36? Yes. Because you got to look at your pattern first to determine what is the relationship between X and Y. This is my weeks, this is my dollar. 1 week, $60. That's not correct because we figured out 1 week was $6. 6 weeks is not $60 because that would mean Ted is saving how much each week? 10, which is your $10 up here. That is not. It's about my savings. Okay, number 9. Tina owns a flower shop. The table shows the prices for different number of flowers. She makes a graph that compares the number of flowers to the total price. So number of flowers to the total price. Number of flowers to the total price. That's what she's doing. Okay? So something's happening here. So which order pair should not be on the graph? Okay, well if we were to continue it, so 2 flowers is $3. 4 flowers is $6. 6 flowers is $9. How much would 8 flowers be? How much would the price be? Be 12. Because if you're noticing, you're increasing. You're increasing by 1, you're increasing by 2, 3, 4, 5. So 10, how much would my price be? $15. So is this going to be on here? 8 and 12. Yep, that's on there. 6 and 4. Is the relationship 6 flowers to $4? Absolutely not. Is my relationship 6 flowers to $9? Sure is. And 10 flowers is $15, which is right here. So that is why B is incorrect. Again, it's a relationship between your X and your Y. All right, number 10. Steve mixes 4 cups of grape juice with 3 cups of ginger. Okay. Ginger ale to make a punch. Steve makes a graph to compare the amounts of juice needed for several batches. Which order pairs could be on the graph? So right here, your relationship between cups of grape juice and cups of ginger ale. So for 4 cups of grape juice, I'm going to use 3. So first of all, my first order pairs would be 4, 3. Okay? So that is correct, that is not correct, that is correct, and that is not correct. So 4, 3. Then you go to the next one. So thinking, okay, well, does it make sense? So again, you have to look at the relationship. Look at your numbers, 4 and 3. You're obviously using more grape juice than ginger ale. So at 4, 3, what about 5? 5 what? Be 5, 4. 6, 5. Again, it's a pattern. 7, 6. 8, 7, and so on and so forth. So which one of those would not work? Would 5, 4 work? Sure does. 6, 5, that works. 4, 3 works. Is 8, 6? No. 8, 6, run 8, jump 6? No. And then 12, 9, run 12, jump 9? No. So, oh, sorry. This is right here. Sorry. So my answer is A. All right, let's look at question number 11. It says, Rob is making a fruit punch for his party. Okay, he adds 4 cups of pineapple juice for every cup. So again, your relationship is C and C, orange juice to pineapple juice. So for 1 cup of orange, 4 cups of pineapple. 2 is 8. So again, what are we doing? We are multiplying. It's a multiplicative pattern. We're multiplying 4. So what would be my amount of pineapple juice for 3 cups of orange juice? 12. So my ordered pairs would be 3, 12, which is answer C. Okay? All right, so then you're going to look at the gold pages. You are not going to turn this in. We're going to walk through this just like we did yesterday. Okay? I want you to look at number 1 and 2. Number 1 talks about multiplying the number of cans by 3. So it's telling you. So 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So again, for 1 can is 3 balls, 2 cans is 6, 3 cans has 9, and 4 cans has 12 balls in there. Okay, those are just tennis balls. So again, you're going to, I don't have enough room, but this would be my cans, and this would be the balls. It's a relationship. So for 1 can, it would be 3. For 2 cans, it would be 6, output 6. Input 3, my relationship would be 9. The output would be 9. 4, my relationship, or my output would be 12. So again, the relationship between my cans and the number of balls in the cans is multiplying by 3. So for 1 can, it's 3, 2 for 6, so on and so forth. Okay? So I want you to complete number 2 by yourself. I'm going to give you a second. Press pause, complete it, and then let's look at mine. Okay. So now if the add input is 2, you're going to add. 1 plus 2 is 3, 2 plus 4 is 4, 3 plus 2 is 5, 4 plus 2 is 6, 5 plus 2 is 7. So again, your input is 1, your output is 3. So 2, 4, 3, 5, 4, 6, 5, 7. All right, let's look at number 3. It says write 4 ordered pairs that represent the pattern, multiply input by 4. So we're going to multiply our input. So here, you honestly can do any kind of. So if you were to want to do skip count, you could do 2, 4, 6, 8, 10. Oops, excuse me. 10, 12, 14. Okay, something like that. Same here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So if my input were to be 2, and I'm multiplying my input by 4, what would be my output? So 2 times 4 is 8. So 2, 8. My next input would be 4. What would be my output? 4 times 4 is 16. So as you notice, it probably wasn't very smart of me to do this right here, being that I can't put another one because 6 times 4 would be 24, and that's way off. So again, you have to kind of be careful. It's probably easier to skip count on your y-axis than it is your x-axis. But nevertheless, I want you to make sure that you're following the rule, because 2 times 4 is 8, 4 times 4 is 16. You're inputting 2, and you're multiplying your input by 4. All right, number 4, it says an architect makes a drawing of a building. 1 inch in the drawing equals 10 feet in the actual measurement. So literally it's telling you 1 inch in the drawing, 1 inch in the drawing is 10 feet in the actual measurement. 10 feet in the actual measurement. Use the table and coordinate grid to continue. So if 1 is 10, 2 inches is going to be 20 actual feet. 3 is going to be 30 actual feet. 4 is going to be 40 actual feet. 5 inches on the drawing is really actually 50 feet. Okay? So it says use coordinate grid to show the pattern. So again, my pattern over here is 1. So this is my drawing. And over here is my actual. Even though it doesn't have it, I'm showing you how to label it, because you will get to the point where you're labeling it. So 1 drawing is really actually 10. 2 inches of drawing is actually 20. 3 inches of drawing is actually 30 feet. 4 inches drawing is actually 40. 5 inches drawing is actually 50. So then the question is, what is the actual measurement at the length of the graph? Drawing is 7. 7 units right here. What is it going to be? It's going to be 70 feet actual. So my coordinate would be 770. 770. Okay? So we're going to look over there on the back page of 14.3. I'd like for you to answer 6 through 9. Press pause, answer 6 through 9, and I'll quickly go over it and we'll talk about it. 6 through 9, it's just 4 problems, making sure you're careful on your multi-step. Alright, number 6. Obviously you see that it is multiplying by 6. It's a multiplicative pattern. So therefore, how many bulbs will be in 4 packages? And it's 24. So 4, 24. Again, the relationship is packages and bulbs. This one is a little bit harder on number 7. It says for every $1 of the student raised for the new playground equipment, the parents associating will do $10. So if it's 1 for 10, so therefore 2 will be $20. $3 for the students, the parents will donate $30. Again, this is student, parent, student, parent, student, parent. So for every 1 is 10, 2 is 20, 3 is 30. So what is my pattern? It's multiplying by 10. So whatever my student and my parent, student and parent, student and parent, student and parent. So one of these is continuing with the pattern of multiplying by 10. And what number is that? Letter, it's C. This is adding. This is not an additive pattern. This is taking away. That is not correct. That is multiplying by 10, and that's multiplying by 100. All right, Shakira saves $2 for every $3 that she spends. Okay? She makes a graph, compares the amount of spent to the amount it saves. Which ordered pairs can be on her graph? So again, for every amount she saves, for every $3 she spends. So she spent. So again, if your spent is your your x-axis. This is your spent. This is your save. This is your spent. So she saves $2 for every $3 she spends. So again, look at the relationship between your numbers right here. So she spent $3, she saved $2. So that means if she spent $6, she saved $4. So if she spent $6, so spent 6, she saved 4. So if she spent $9, she's going to save, oh, excuse me, that's incorrect, $6. So 9 and 6. Okay? So again, the relationship is what's happening here. Okay? The relationship is you are spending more than you're saving. So again, this is your spent and your save. So looking at it, you've got a larger number and a smaller number. A larger number, smaller. A larger, smaller. So you could even do something like that. Larger, small. Nope. Larger, small. Nope. Larger, nope. Oh, look. Larger, smaller, larger, smaller. So again, looking at the pattern, is it even fair that she did 3 to 6? No. We already did this right here. 2 to 3? No. Her first one was here. She spent 3, she saved 2. So this would be the only 2 that might be even an option. Excuse me, this 2. Oh, I apologize. So your answer is D. Multi-step number 9. When the cook at Barney's restaurant makes chili, he adds 3 cups of water. Okay, so there's my water, so that's my Y, and this is my X. So again, my X and my Y. So tomato and chili. So again, tomato is my X, chili is my Y. Oh, I'm sorry, tomato sauce. This should be, oh geez, I can't erase. This is my water, is my Y. So I apologize. Water is Y. So when the cook at Barney's restaurants makes chili, he adds 3 cups of water for every 2 cups of tomato sauce. if you make a graph to compare the amounts of tomato sauce needed for several batches of chili, which ordered pairs can be on the graph? It's the same thing here. So if I double it, again, recipes you double. So now you double this. What's doubling of 3? It's 6. If I double it to 6, then I have to double my tomato sauce, and it will be 4. Okay, if I triple it, if I had 3, now I triple 3, what is that? 9. If I triple this, it's going to be 3 times, it's going to be what? 6. If I quadruple it, which is 4 times, what would it be? 3 times 4 is 12. If I didn't quadruple this, so this would be 8. Which one of those is from the ordered pairs that matches that? It's D. Tomato, water, tomato, water, tomato, water. All of those, tomato, water, tomato, water, tomato, water, tomato, water. First of all, look at my first ordered pair. That doesn't match my first ordered pair. This does not. So that matches my first tomato to water. It literally tells me tomato, water. You connecting the dots. What is tomato? That's my X. And this is my Y. You've got to really be careful. All right, so let's look at 530. This is 14.4. Same thing here. Same thing here. I want you to look at number 1. I want you to complete number 1. Okay, so look at number 1. Completed it for you. You're multiplying. It literally says multiply the number of tablespoons by 2 to get your weight. So again, the relationship is 2 tablespoons of butter is the same as 4 ounces. 3, 6 ounces. 4 tablespoons is 8 ounces. And you're plotting it. Again, your butter is your x-axis, so that's why your input is 1. Oh, whoops, I forgot to do 2. 2, and then my output is 4. My output is 4. Input, output, input, output, input, output. Butter is your x-axis. Weight is your y-axis. Again, nothing new. Okay, let's look at 532. Let's look at 532. Number 8 says the table compares the distance of map and real distance. How many miles did the map distance of 6 inches represent? So here's your input and your output. So you're looking up at the relationship between what's happening. So what's happening from 1 to 6, 2 to 4, 2 to 12, 3 to 18, 4 to 24. What am I doing? I'm multiplying. Multiplying by 6. So if it's saying 6 inches, oh, they're asking me, if I were to continue the pattern and they're telling me 6 inches, that is my input. So therefore, what is my output? 36. C. Okay. All right, so you're going to use this graph over here on the right to look at questions 9 and 10. So again, let's look at our graph. Number of pins is my X. My Y is my cost. X, Y. X is pins. And this is my cost. So it cost me for 5 pins, it's $1. So 5 pins, it's $1. 10 pins, it's $2. 15 pins, it's $3. 20 pins, it's $4, and so on and so forth. So which statement about the data is correct? 1 pin costs $5. Does 1 pin? There's no 1 pin. 4 pins, is there a 4 pin? Nope. 2 pins? Nope. Oh, geez. 5 pins? Yes. 5 pins cost what? $1. That is correct. Okay, again, looking at the relationship. Suppose Jake buys 30 pins. He also buys a notebook for $3. How much does Jake spend? So if Jake buys 30 pins, oh, my pattern doesn't continue. So 30, my pattern continues. So he buys 30 pins. That's going to cost him $6. He also buys a notebook. Oh, I'm so sorry. My pattern continues right here. So 30, pattern continues, which would give me $6. And he also buys a notebook for $3. And that's going to get me $9. All right, number 11. Dubber, doesn't matter, plots a pattern showing the number of pentagons and the total number of sides for that pentagon. So pentagon has 5 sides. So if the x-axis and the y-axis, so the x is the number of pentagons. Okay, so the number of pentagons is 8 pentagons. Which ordered pairs? So then the y is the sides. The number of pentagons and the sides. So this is sides. So this is your number, this is your side. So if there's 8 pentagons, how many sides? Well, what did I just say? Pentagon has 5 sides. So if 8 pentagons, how many sides is that going to be? 40. X is 8, Y is 40, so therefore my ordered pairs is 8, 40, which gets me D. Okay? So now what you're going to do, you're going to work on and you're going to complete, tear out 14.4. Both sides need to be completed and turned in. Turn it in when you're done.